I got 2 questions tonight on the AP exam practice questions for chapter 3, so number 3 and 7. And number 3 says the position of an object along a vertical line is given by this position function. Negative t cubed plus 3t squared plus 9t plus 5. And it says where s is measured in feet and t is measured in seconds. It wants to know the maximum velocity. So the position, the velocity is the derivative of the position. So negative 3t squared plus 6t plus 9. It wants to know the maximum of this curve. So there's 2 ways we can do this. Number 1, since the velocity is a quadratic, I can find the maximum on the interval from 0 to 4. So the maximum of this velocity function just by finding the vertex, negative b over 2a equals negative 6 over 2 times negative 3. Negative 6 over negative 6 is 1. So the maximum velocity is 1 comma, and if I plug in 1, I get negative 3 plus 6 plus 9. So that's 15 minus 3, which is 12. So that would be answer B, 12 feet per second. If I also wanted to know the maximum, I could find the derivative of this and its critical point. So the derivative of this, it becomes acceleration, but we can focus on this, the derivative of negative 6t plus 6. Find that critical point, so you get negative 6t equals negative 6. You get t equals 1. And so if 1 is a critical point, you test prior to 1 like it's 0, and you get that it's increasing. And if you plug in something after this, you get it's decreasing. So the velocity function, the derivative, shows that it's increasing prior to 1 and decreasing after 1, which makes it a maximum at 1. One thing that I never showed you guys, and in light of this vertex, I will now. So we wonder, and we were told actually in Algebra 1, hey guys, if you want to find the vertex, just do negative b over 2a for a quadratic. Well, the reason for that is because if your function is ax squared plus bx plus c, and that's your quadratic format, the derivative of that is 2ax plus b. And if you're looking for a critical point, you set it equal to 0, you subtract the b over, and you divide by 2a. And your critical point is at negative b over 2a, which is where that vertex formula comes from. Kelly, how do you like that? Because I know that you're watching this. If nobody else, I would have shown you that in class for the first time. We can kind of understand why negative b over 2a is what we use in Algebra 1. Now in Algebra 1, we just say, hey, look, someone awesome found this formula. Go ahead and use it to find the quadratic. But the reality is it comes from derivatives. It comes from the critical points, which help you find maximums, where something's increasing and then decreasing, or minimums, where something is decreasing and then increasing. So just a neat little tidbit. If anybody else is watching this and thinks that that's cool, send me a separate message and let me know how cool you think that is, because I appreciate it. And number 7 says, if the mean value theorem is applied to the function f of x, ln, on the interval from 4 to 8, then the number c that must exist in 4 to 8 is blank. So the mean value theorem says the average rate of change from 4 to 8 must be achieved at least one time. So the derivative, well, let me do it this way. 4 when I plug it in on the function, gives me the natural log of 1, which is e to what power gives me 1? 0. If I plug in 8, the natural log of 5, and this is a calculator section, so I'm going to look that up. Natural log of 5, 1.609. So my average rate of change is 1.609 divided by 4. y2 minus y1, x2 minus x1. So divide that by 4. So that is 0.4023. So we're looking for the location that has a slope of 0.4023. So I'm going to find the derivative of the natural log of x minus 3, which is just, if this is u, you get u prime, which is 1, over u itself, x minus 3. So when does that equal 0.4023? So I would cross multiply, distribute 0.4023. Now that's rounded, so I'm a little bit nervous by that. I'm going to keep the actual numbers on my calculator. Minus times 3. .207078434. So I'm going to add that over and divide that by the 0.4023 number. And I'm going to get that is occurring at an x coordinate of 5.48533, which is option A. So to summarize, I find the average rate of change starting with 4 to 8. So if I want to give you guys a visual, which I would always do to fully help us wrap our head around this. So here's what's happening. From a window of 4 to 8, I'm going to go -10 to 10. We'll open it if we have to. Okay, we don't need that much. Maybe -2 to 2. Maybe -5 to 5 would work. Let me turn this light off. Window -5 to 5. Okay, so the average rate of change there, start to finish, is a line with a slope of 0.4023. So we're going to look for the actual location on there that has a slope of 0.4023, and that's happening at 5.485. So I'm trying to think how I would value 5.48533. So right there, if I were to draw the tangent line, it would be parallel to the average rate of change line, start to finish average rate of change, and then the tangent line right there would be parallel to that. So that C value, for which the slope is exactly the average rate of change, is that. That one's not as exciting, but a little bit yucky because of the decimals, but you had a calculator on that one. So hope everyone has a good night.